The laws of physics as we know them may not be the lowest energy state of the universe. They may be a temporary configuration, stable enough to persist for billions of years, but not permanent. If this is true, the universe exists in what physicists call a false vacuum, a state of apparent stability that is not the ground state of reality. The analogy sometimes used is a ball resting in a shallow depression on a hillside. It appears stable, but it is not at the bottom of the hill. A sufficient disturbance could send it rolling into a deeper state. At some point, somewhere in the universe, a quantum fluctuation could initiate this transition, a spontaneous tunneling to a lower energy configuration of the Higgs field. This would produce a bubble of true vacuum, expanding outward in all directions at the speed of light. Inside that bubble, the laws of physics would be different. The fundamental constants, the values that determine the structure of atoms, the behavior of matter, the existence of chemistry, would not hold. Nothing inside could survive, not because of heat, pressure, or radiation of any kind, because the rules that allow matter to exist would no longer apply. The bubble would be undetectable. It would not emit any signal that could outrun it. There would be no warning, no precursor, no time to observe it approaching, because it travels at the speed of light, and any information about its existence could only arrive at the same moment the bubble did. Whether we are in a false vacuum depends on the precise values of two quantities, the mass of the Higgs boson and the mass of the top quark. Both have been measured at particle accelerators. The Higgs boson was confirmed at approximately 125 giga-electron volts. The top quark at approximately 173 giga-electron volts. When these values are entered into the equations governing the stability of the Higgs field, the result places our universe in a region called metastability. Not clearly stable, not clearly unstable. The error bars on both measurements are large enough that we cannot conclusively rule out either possibility. Some calculations suggest the vacuum is stable. Others suggest it is metastable, in which case a transition is possible, but expected to be unlikely on timescales far longer than the current age of the universe. These calculations depend on physics at extremely high energies, near the Planck scale, where our models may not be complete. If we are in a metastable vacuum, the transition could have already begun. It could have started billions of years ago in a distant galaxy that we can still observe. The bubble would be expanding toward us at the speed of light right now. We would have no way to know. We have not observed any region of the universe undergoing vacuum decay. This is not strong evidence that it has not occurred. A bubble expanding at the speed of light would be indistinguishable from empty space until the moment it arrived. There is no instrument we could build. There is no observation we could make. There is no warning system that the laws of physics allow. If vacuum decay is possible, it is permanent, instantaneous, universal, and silent. It is a physical scenario that could occur at any location, at any moment, without any indication that it is happening until it has already reached you.